In the last section, we looked at an iterative solution to the steps problem. In this section, we're now going to continue by looking at a recursive solution to this. Now, if you're here in this course and you're preparing for a professional JavaScript interview, I am going to assume that you have seen recursion before, at least once. Nonetheless, we will do a very quick review just to make sure that we are on the same page. We'll then look at a couple of general tips around recursion, and then we'll come back to this problem and figure out how to tackle it. So let's do a quick review. First, with recursion, we always start off with some type of function. So let's imagine that we've got a function called, how about print number? How about that? Let's imagine that we want to make a recursive function called print number. We should be able to pass this function a number, and it will print from that number down to 0. So we'll assume that we always pass this thing a positive number. Let's write out an example of that. So let's pass it like the number 10. So we'll say that to succeed in this problem, I want to see a console log from 10 all the way down to 1 or 0, one or the other. And the first thing that we always do with a recursive solution is to identify what is called a base case. The base case is the case in which we decide there is no more work for us to do and it's time to return and stop the recursion process. And so without even thinking about the term base case or anything like that, think back to the description of this function that I just gave you 2 seconds ago. I said we want to print from whatever number's passed all the way down to 0. And then at 0, we stop and we do no more work. So to think of a base case in this situation, I would say that if the number that is being passed to this function right here is equal to 0, that means there is nothing else we need to do. We have hit the base case and we want to stop recursion. So let's write that in here. Let's imagine that print number gets called with some number n as an argument. We will check to see if n is equal to 0. And if n is equal to 0, then we are going to return and we're going to do no more work during the recursion process. Nailing your base case like this is one thing that is absolutely critical during the recursion process. I really encourage you to spend a lot of time in general thinking about your base case. It's way too often that people start to think about base case only at the end. And if you think about the base case only at the end, well, usually it means that if you try running your function before then, you'll end up in an infinite recursive solution, which is always nasty to try to debug. So always start thinking about your base case from the get-go. After checking to see if we've met the base case, we will then do some amount of work and then call our function again. So in this case, the work that we want to do is to print out the current number n. So I'm going to print out with the console log n. Then the last thing to do is to call our function again. When we call the function again, it's extremely critical to make sure that we have changed the arguments in some fashion. If we call print number again with n, we're going to immediately enter an infinite loop because we have not changed the arguments and the exact same code path will occur. So I'm going to be 100% sure that I'm going to change the arguments that I'm going to call print number with here. And I'm going to make sure that the change that I'm making will somehow eventually get our n number here down to 0. So specifically, I mean to say I'm going to make sure I subtract 1 or subtract some type of number. Okay, so when we call print number again, and this of course right here is the actual recursive step because we are calling the function that defines that this function call is defined in again, then we see our numbers printed out here. Now you will notice that you see 2 if you're using this tool, or if you're just looking at my screen, you'll notice that we get 2 sets of prints from 10 down to 1. That's just because of the way that this tool right here behaves. The code that we have is 100% correct. It's just because of the way that this tool works to make stuff print out nicely that you see the log out here twice. Okay, so what are some takeaways that you can immediately notice about recursion from this process right here? Here they are. So the first thing that we really want to do is to identify the bare minimum pieces of information that represent what we are trying to accomplish. So in this case, the bare minimum piece of information that we want to pass from loop to loop, or from, I should say, call to call of our recursive function is the current counter. I did not pass along some extra piece of information like what the number was the last time it was called, or some object that we're not doing anything with. I identified just the bare minimum information that was needed to call our function again and progress towards our base case. The next thing to keep in mind with recursion is to always give yourself some reasonable defaults to those minimum pieces of information. So in this particular case, we had said that we were going to provide the number and then always subtract 1 to get towards our base case right here. But let's imagine that maybe we had said, or maybe an additional requirement of the print number function was that it should be able to be called with some number to decrease n by each time. So in other words, maybe we don't want to always decrease by 1, maybe we want to decrease by some other argument here that maybe we'll call decrement or something like that. So this second step right here, giving reasonable defaults, make sure that if there are any optional inputs, you give some reasonable default input to them. So in this case, I would want to maybe default the value of dec to be 1. And then I could very safely use it down here at print number. And even if someone didn't pass in that dec variable or the dec value, I've got some reasonable default to make sure that I don't accidentally fall into some infinite recursion situation right here. For example, I can very easily show you if I were to, and I'm not going to because my browser would lock up, but if I were to delete this declaration right here of dec, or if I were to not default it to be 1, then every single time we called print number, we would take n minus dec. Dec would be undefined if I didn't default it to be 1. We would then call print number again. N would probably be like not a number or something like that. And so we would never hit the case where n equals 0 and return. So make sure you have some reasonable default in here to safely handle your recursion. The next thing to do during the recursion process, always remember to check that base case. Inside the base case, you want to see, is there anything left for us to do? If there's no work, that's it, we're done. Okay, don't call our function anymore and return. If we do not meet the base case, then we want to make sure that we actually do some work. We call the function again, and whenever we call the function again, this is a really important part, whenever we call the function again, we want to make sure that we have changed our arguments in some fashion. The arguments have to change. If they don't change, that means that we're very likely going to end up in an infinite recursive solution, which is, again, something we don't want to deal with. Okay, so with all this in mind, let's take a quick pause. We're going to come back in the next section and we're going to apply these rules right here to the steps problem, and we're going to come up with a recursive solution. So quick break, and I'll see you in just a minute.